So we come to question number 16. It says, for 25 ml of PbI2, 13.3 ml of a certain AgNO3 solution is required for complete neutralization. Find the concentration of the AgNO3 solution if you're given that PbI2 solid is in equilibrium with Pb2 plus aqueous and 2I minus aqueous, and the Ksp of PbI2 is 7.1 into 10 to the power minus 9. And also it's given that Ag plus I minus is in equilibrium with AgI solid.
Okay, so I know the neutralization reaction. It is Ag plus I minus is in equilibrium with AgIs. So basically AgNO3 is neutralizing the PbI2. Essentially, the I plus I minus ions are reacting with Ag plus ions and getting neutralized. So for neutralization, I know M1V1 should be equal to M2V2, right? So M1 here will be the concentration of I minus ions because they need to be neutralized.
That's right.
In a solution of 25 ml. And for AgNO3, I need to find out the concentration of AgNO3 solution, and the volume of AgNO3 solution required is 13.3 ml.
Right.
So I need to find out M2 and I minus concentration. The I minus concentration I can find out by utilizing the concept of Ksp and solubility. Let's see how. PbI2 solid is in equilibrium with Pb plus 2 aqueous plus 2I minus aqueous.
That's right.
So this salt PbI2 in aqueous solution will dissociate into Pb plus 2 and 2I minus, and the equilibrium constant for this solubility reaction is given as 7.1 into 10 raised to the power minus 9. Let's say S moles of Pb plus 2 and 2S moles of I minus are formed after dissociation. How will we write the expression for Ksp? Let's see.
Right.
S will be raised to the power of 1 because the stoichiometric coefficient of Pb plus 2 is 1, and 2S will be raised to the power of 2. So 4S cube is equals to 7.1 into 10 raised to the power minus 9. I can solve this for S, which is 1.21 into 10 raised to the power minus 3. So the concentration of I minus is 2S, which is 2.42 into 10 raised to the power minus 3 molar.
That's right.
Now I can substitute these values in the equation A, and I will obtain 2.42 into 10 raised to the power minus 3 into 25 is equals to M1 into 13.3. So M1, which is the concentration of the AgNO3 solution, we will obtain from this equation as 4.55 into 10 raised to the power minus 3 molar. So this is the answer.
Yeah, that's right. So basically here we use the concept of Ksp, and it's not a very difficult question, just the calculation being a little tedious one. Just go through it carefully and practice would just get you there. So this was question number 16. So question 17 says, arrange the following Lewis acids in the decreasing order of their acidic strength. The acids being HClO4, HClO3 and HClO2. So how will we proceed?
According to the Lewis theory of acids and bases, Lewis acid is an electron pair acceptor, and Lewis bases are electron pair donors. So if we see these acids one by one, this is oxygen, Cl, O, O, O. This is the structure of HClO4. This is structure for HClO3. Okay. Now we know that oxygen has very high electronegativity. It's an electron withdrawing group. So here there are 4 oxygens. So this Cl, this chlorine here will be very electron deficient. So, and if you compare this with HClO3, then here there are just 3 oxygen atoms.
That's right.
So this, the chlorine atom in the first case will be a better electron pair acceptor than in the second case. So therefore HClO4 is a stronger acid than HClO3. Similarly, if you compare these two, then here there are only 2 oxygen atoms. So this chlorine atom in HClO3 will be highly electron deficient as compared to HClO2. So HClO3 will be a stronger Lewis acid than HClO2. So this is the correct order of the
increasing acidic strength
according to the Lewis concept.
So this, you saw a question on the Lewis acid concept, and this is you just need to go through this concept and the rules of bonding quite well to do the question. So this was question number 17. So now we come to question number 18, and it says MbR2 with a concentration of 0.05 molar is saturated with H2S. Now we have to find the minimum pH at which the salt Ms will precipitate, and we are given the Ksp for Ms and that H2S concentration is 0.5 molar, and we are given 2 reactions, the first one being H2S is in equilibrium with H plus HS minus, and Ka1 for the reaction is 10 to the power minus 7. And secondly, HS minus in equilibrium with H plus S2 minus, and Ka2 for H2S being 1.3 into 10 to the power minus 13. And we have to find the minimum pH at which Ms will precipitate.
Yeah. So let's see what has been given to us. The concentration of H2S is 0.1 molar. Ka1 for H2S is given as 10 to the power minus 7, and Ka2 for H2S is given as 1.3 into 10 to the power minus 13. And if we add the 2 reactions, if we have to find out the overall acid dissociation constant, we can just add the 2 reactions, these 2 reactions, and we will get H2S is in equilibrium with 2H plus S2 minus, which is the reaction for the dissociation of H2S acid. So for this, the dissociation constant Ka3 will be Ka1 into Ka2. We had discussed this earlier, that when 2 reactions are added, their equilibrium constants get multiplied. So here I will obtain 1.3 into 10 raised to the power minus 13 into 10 raised to the power minus 7, which is 1.3 into 10 raised to the power minus 20. Okay. Now we need to remember that a salt precipitates only when the reaction quotient is greater than the Ksp of the salt. This is extremely important. This is the catch in the question. So now the reaction quotient for the salt Ms will be given by concentration of M plus 2 into concentration of S2 minus.
That's right.
This should be greater than Ksp, and the value of Ksp is 6 into 10 raised to the power minus 21. And since I need to find out the minimum pH, I will work with an inequality, obviously. And the concentration of MbR2 salt is given as 0.05 molar. So when the salt dissociates, the concentration of M plus 2 will be 0.05 molar.
That's right.
So we can substitute this to obtain S, this inequality, S2 minus should be greater than 6 into 10 raised to the power minus 21 upon 0.05 molar. So concentration of S2 minus should be greater than 1.2 into 10 raised to the power minus 19. So this means that this is the minimum concentration of S2 minus which I require.
Right.
This I can use to calculate the minimum pH. Let's see how. For the acidic dissociation of H2S, I can write this reaction, and I know that the acid dissociation constant is 1.3 into 10 raised to the power minus 20 for this reaction, and I can write this expression H plus square into S2 minus concentration upon the concentration of H2S.
Right.
Now I know the concentration of H2S is given to me as 0.1. Right. And I found out the minimum S2 minus concentration required. So when I put all those values in this equation, I will get the minimum H plus concentration required. So H plus minimum square into 1.2 into 10 raised power minus 19. So from here I will obtain H plus square as 1.083 into 10 raised to the power minus 2, and concentration of H plus, this is the minimum concentration because I'm working with the minimum S2 minus concentration.
That's right.
So, and pH is nothing but minus logarithm of H plus ion concentration. So pH I will obtain as 0.98. 0.98.
That's right. So basically what's the catch of the question was the condition of precipitation, and it is often used in many questions in ionic equilibrium, especially of salts and precipitation. So you just need to be careful with that, and again with the calculations you need to be careful. And this was question number 18. So we start with question number 19 now. That is, for the weak base B and HCl with concentration of 0.02 molar each, find the volumes of acid and the base that must be taken to obtain a solution of volume 400 ml in order to maintain a pH of 7. The dissociation constant of the base pKb is pKb is equal to 7.09. How will we do this?
Yeah. So in the question, I know the value of pKb for the base is 7.09. The concentration of the base is 0.02 molar, and the concentration of HCl acid is 0.02 molar. The volume, I need to add base and acid in such a way that the total volume is 400 ml, and I obtain a buffer with a pH of 7. Yeah. So buffers, as we discussed earlier, are used to maintain the pH of the solution at a particular value.
Exactly.
Yeah. So let's say we take V1 volume of the acid and V2 volume of the base and add them. The volume should be 400 ml.
That's right.
Now for this the base, what is a basic buffer? It's basically the mixture of a weak base with its salt with a strong acid.
That's right.
But for the buffer action, the volume of the base, weak base, should be greater than the volume of the strong acid.
Right.
For basic buffers. So when I add the acid and the base, this reaction will take place. The salt BCl will be formed. So I know that the concentration of the acid and the base are 0.02 molar each, and the volumes also I've assumed as V1 and V2.
Right.
So initially at time t is equals to 0, this is the scenario. At a certain instant of time t is equals to t, since the amount of base is less than the acid, neutralization will take place and I will be left with initially let's also talk about the number of moles.
Exactly.
So number of moles are 0.02 into V2 into 0.02 into V1, 0 and 0. Neutralization will take place at time t is equals to t. Let's say, first of all, since the amount of base is less, this will be utilized completely. So I will be left with 0.02 into V2 minus V1 because 0.02 V1 moles will be utilized, they will be consumed, and then I will obtain 0 and 0. We will obtain 0.02 V1 moles of salt. So yeah, and the pH of the buffer has to be maintained at 7. So the pOH is also 7 because we know that pH plus pOH is. I know the formula for pOH of a basic buffer, which is pOH is equals to pKb plus log of concentration of salt upon the concentration of base. I'll substitute the values. POH is 7, pKb is given to me as 7.09, plus log of concentration of salt is 0.02 V1, and the concentration of the base, which is finally left, is 0.02 into V2
Right.
minus V1. So when I solve this, I will get V1 upon V2 minus V1 is 0.8128.
Exactly, by simple mathematical
Yeah.
calculation.
So now it's very easy to solve. I can obtain V1 as 0.4484 V2, and I know that V1 plus V2 is 400. So these two equations can be used to solve for the two volumes. The final
Exactly.
answer will be V1 is equals to 123.8 ml. This is for the acid, and V2 will be 276.2 ml, which is the base.
Exactly. So basically here we need to pay concentration on the fact that we used the difference of volumes in applying the formula, and secondly just go through the mathematical calculations to solve the questions, and basically the concept of buffer was used in this, which is actually very common in exams now. So this was question number 19. So coming to question 20 now, calculate the equilibrium constant for the reaction Cn minus plus CH3COOH is in equilibrium with HCl plus CH3COO minus, and the Kb for Cn minus is 2.04 into 10 to the power minus 5, and the Kb for CH3COO minus is 5.55 into 10 to the power minus 10. So how will we proceed in this question?
Yeah. So I know the Kb for Cn minus. It's given to me as 2.04 into 10 raised to the power minus 5. So basically, how do we proceed? Let's proceed with whatever has been given to us. Kb, that is the dissociation constant of a base.
Right.
So I will write the reaction in which Cn minus acts as a base. So this is the reaction. It will release OH minus ions and form HCN.
That's
This is
right.
the reaction. So Kb can be written as concentration of HCN into concentration of OH minus upon concentration of Cn minus, which is 2.04 into 10 raised to the power minus 5.
Right.
Let's name this equation as 1. Similarly, I can write the expression for the Kb of CH3COO minus as CH3COOH into OH minus upon CH3COO minus, which is 5.55 into 10 raised to the power minus 10. It is equation 2.
That's
The
right.
reaction will obviously, we can easily obtain it. The reaction will be this. So now, if you notice, we need to find out the equilibrium constant for the given reaction, which will be concentration of HCN into concentration of CH3COO minus upon the concentration of Cn minus into CH3COOH.
Right.
So, if you notice carefully, this expression can be obtained if I divide equation 1 by equation 2.
That's true.
That's true, right? Let's see how we do that. If I divide 1 by 2, I will obtain Kb. Let's name this as Kb dash. Upon Kb dash will be concentration of HCN into concentration of OH minus upon concentration of Cn minus into concentration of CH3COO minus upon concentration of CH3COOH into OH minus. This will cancel out and we'll obtain the expression for equilibrium constant.
The K equilibrium.
So
right.
I can, for K equilibrium, I can substitute the values of the dissociation constants for bases, which will be 2.04 into 10 raised to the power minus 5 upon 5.55 into 10 raised to the power minus 10, and therefore I will obtain the equilibrium constant as 3.676 into 10 raised to the power 4.
That's right.
So that is the answer.
So basically in this question, this question in the beginning it seems that nothing is given in the question, how do we proceed, but it is actually not that difficult, and just we obtained the ratio, and carefully applying the formulas of KB, KB dash and the K equilibrium, we obtained our answer. So basically you just need to be thorough with your concepts and good in practice. So this was question number 20.